So welcome everybody to another episode of Software Architecture Stream. This time around from OP conference, and we are starting, OP actually started today, and we are starting OP conference this evening with the English evening. Tomorrow we'll have a few shorts during the lunch break, and then we will have the climate panel and the diversity panel on Wednesday and Thursday, all of them in German, I'm afraid. So this is the only English part of the program. And first session will be about facilitating collaborative design decisions. So that's what we're going to talk about here. Then my colleague Lisa will talk with Rick Marselis about testing and quality. And then I will talk with Scott Ambler about data technical debt. So that's what we are going to do today. And a warm welcome to Gien, Evelyn, and Kelle. They are going to do a tutorial on Friday for facilitating collaborative design decisions. That's what we are going to talk about today too. So do you want to say a few words about yourself? Who wants to start? Gien, do you want to start?
Sure, I'll start. Hi, everyone. My name is Gien. I'm from Belgium. I am a software consultant that specializes in F# and making a decision theory. Sorry, I was distracted by my cat. I was doing weird things here. Yeah, so I specialize in decision theory as well. That's basically something that's more known in the economics, and I try to read things about it and then see how we can apply it to software. Kelle, why don't you tell a bit about yourself?
Yeah, my name is Kelle Baas-Schwegler, Schwegler, depending from where you come from. I always say Schwegler in Dutch. Sorry for that. No, I'm a background in electrical engineering, rolled into software development, and then caught off to domain-driven design. And now my current focus is mostly the parts of visual collaboration and strategic design, while you need technical design as well. But I focus mostly on that, thanks to my wife, background as social scientist, and thanks to working, of course, with Evelyn. Evelyn, off to you.
Oh, nice bridge. Okay, I'm trying to not get distracted by the cat as well. So I'm Evelyn, also a strategic software delivery consultant and a behavioral change consultant. And as Kelle mentioned, I have a background in social sciences as well, so cognitive psychology, to be more specific. And I'm a strong believer in these so-called socio-technical systems, where we really need to balance the socio-technical and cognitive aspects. So what I do on a daily basis, I help teams and leadership teams specifically to steer on the social and behavioral consequences that are implied by technical choices and the other way around. And I do that by using a number of techniques and tools and practices and methods, including domain-driven design. And that's in a nutshell, I think, what I do. Yeah.
Interesting. So quite a few different perspectives in the session today. So that's great. Well, first of all, why would I do any design decisions collaboratively? I mean, obviously, an alternative would be to get the most senior, most experienced person in the team to make the decision. And obviously, that's going to be a sound decision and a great decision. So why would you collaborate on it?
Yeah. So shall I take this one?
Sure.
Yeah, the simple answer is better thinking, better buy-in, and better decision all around. But also, if you're losing valuable knowledge, so usually the person with the most knowledge has also the curse of knowledge. So they probably don't know what they don't know, and new people who coming in who are maybe more junior. I was for once that person. Might A, have knowledge you don't know, but B, also needs to learn. So it's better to do it collaboratively together. And going into that, the better buy-in, right? The sustainability of a decision is once people don't feel heard in their view, they probably turn into resistant behavior, like that cat is doing now. Cat wants attention, not feeling heard. So and everyone can understand or feel like if they make a decision, all of a sudden people won't do what's been decided, right? Or they're gonna stall, or they're gonna make jokes, sarcastic jokes, or gossip, or, well, they're just not on board with the decision. That's why we call it sustainable decision making, right? So a decision can be made by the technical leader, which sometimes is a good thing, but how do we get the rest on board with and buy in our decision? Which is much easier in a collaborative way, because everyone could put their knowledge and models out, right? So
and
yeah.
you especially also want, I mean, like you were saying, you could just have the most senior or most knowledgeable people in the room, but you do want that knowledge from others as well, because you have this risk that if you only invite the most knowledgeable people, you miss a lot of knowledge and a lot of insights and perspectives. And especially because, well, the more seniority you have, also the higher that you are getting in rank, and then you might becoming way more intimidating for other people to actually speak up. But these people might have actually very valuable and interesting things to say. So that's why we always aim to get like all the domain experts, and that includes juniors, seniors, and everything in between, in order to actually get to the most complete view and perspective and model possible.
Yeah. And there's one other dimension there, right? It has to be on the same scope of architecture. So if you're on different scopes of architecture, you don't need to invite everyone, right? But if you're on the same scope, if you don't include everyone, you won't have a mutual understanding usually, because people will take assumptions, right? If the most knowledgeable person says, this is what we're going to do, you're assuming that the other person is knowledgeable enough to understand your decision and thus act accordingly to your decision, which is, well, by default, never the case, in my opinion. So it's also sharing knowledge between each other, right? Which, well, if you ever been on a situation where you're new, you're usually getting the most easy ticket, right, to do. But that's actually, it's a system trap where the people with the most knowledge always get more knowledge, and even more knowledge and knowledge and knowledge, while the people who are just in will get small knowledge. So they're always behind. So it's better to collaborate on it so that everyone is onboarded quickly, and you don't get that, oh, I cannot go on holiday because I hold all the knowledge problem, or the bus factor, or the lottery factor, whatever you want to call it.
So that's quite interesting, quite a lot of stuff. So what you're saying is there are better decisions, there's better buy-in, and it's also about the roles. One thing that I'm wondering is who should collaborate on the design decisions? So I think Evelyn just said that also domain experts should collaborate on it. So probably engineers, software architects, domain experts, but a lot of architectural decisions are still technical. So why would a business expert be involved on that? So does it depend on the decision who should be involved, or are there any general rules? So what's your take on that?
Yeah, it of course always depends on obviously we're consultants. It always depends on what you want to achieve and what you want to solve. But we feel it's especially important to mix up these, well, business and IT. I'm against those terms, but I get what you're saying, because, well, like we said, every technical choice has a social implication, right? So every technical choice that you're making has an effect on how your organization is organized, or how your teams are structured, or what behavioral changes that implies, which decisions are going to be made, and that also affects the business. So if you are in a room together doing the collaborative modeling, then you can already work with those perspectives, and then you can already account for these factors that will heavily influence each other. You've heard about Conway's Law. Well, that's why you want all the domain experts in a room. So that's one take of it. But my colleagues definitely have other stuff to say about that.
Yeah, it depends on scoping of the architecture. Ruud Malan has and Dana Bredemeyer has this nice scoping, and that relates to also Elliot Jacques in my levels of work. So it depends on what scope of architecture you're including, but let's just take it on a team perspective, right? So of course, if you talk about should we go with what database solution, you generally don't involve the domain expert, but you want to at least beforehand talk to them and know what's their real problem before I know which database solution is the best from things that software engineers don't care about from a money perspective, first of all, right? Which one is more expensive, which one is cheaper. And so you really need to understand, and that comes from domain-driven design, right? The real problem of your domain experts. And of course, there's a period At some point you can say, well, maybe we probably know enough for now. Let's decide on the technical decision together. But of course, there's new feedback, new questions that has a business impact again. So you need to go in return. It's never linear. It's always whirlpooling around. So yeah, you really need to be mindful of when to include and when not. But what you want is to have that shared responsibility together with your stakeholders or your domain experts in your team, right? It doesn't have to be like, oh, this is about database technology, I don't care, do your thing mode, because then it goes wrong, because at some point developers will just find technical complexity to solve instead of domain complexity. And then you have over-engineering.
Okay, cool. Gien, anything to add from your side, or?
So I was thinking about this while Kenny was talking. Like one of the things that some industries do, if you go more general and not necessarily go about design decisions, but sort of trying to solve a specific problem, is that they sort of outsource it because they're stuck in their way of thinking and they don't see a solution forward. So they sort of outsource it. They put it online somewhere, and then everyone can sort of have a look at it. And often the solutions then come in or from people who are, nowhere in that industry. So basically what you're doing is trying to sort of recreate that solution as well. You involve people that do not have, the software development knowledge, because they look at problems and design is a problem you're trying to solve, and they just look differently at it, and they might bring up ideas or thoughts that just would not cross our minds because we are stuck in a certain way of thinking, because we are software developers, because we are architects. So I think that's why it's interesting to involve the right people, or more than just people with a technical background.
Yeah, like and to add to that, because you make a great point there, and this is exactly how you can counter some of the biases that we're all in. We're all stuck in what we know, what we used to do. The people who are always speaking up with the ideas and who always make the decisions, but you kind of want those. Yeah, I want to say naive, but it's not. But the perspectives on stuff and the challenging way of looking at things, like, hey, you've been in this for weeks, months, or maybe even years. You want those perspectives of people that have never seen it and say, well, this is weird, or why did you do this? Why did you make this decision? And that really helps in challenging all of the biases that are flying around in these sessions.
Yeah, and maybe a concrete example, like technology choices, like maybe Vue versus React, right? That can be, if you let engineers go, they will just rationally check which one is best and which one I'm more comfortable with. But you also have a strategic approach that maybe if you need to scale, or maybe that's not between those two, but a like quirky framework, and you want to scale to 200, new developers, then maybe that Svelte JS, which is probably a very nice and very good tool, I don't know, is the best choice, but on a technical perspective, but not from a scaling perspective towards 200 people recruiting, because that's a a recruitment problem, right? So then Svelte might not, or some other very good framework that are out there might not be your choice of technology at this moment. So.
One thing that I'm wondering, I mean, we are talking about how you get buy-in and how you need to include a lot of people in any decision. To me, that sounds like decisions will take forever then. So what do you do how do you feel about that? Is that a problem? How do you deal with it if it's really a problem? So what's your take on that?
I can start.
Go ahead.
But I'm very curious what are the decision theoretical person has to say about that as well. So it now sounds like involving in the decision, and then the image that comes to mind is we're all going to sit around at a table and we're going to discuss the decision that needs to be made, and we're not getting out of the room until we decide something. But involving people in a decision also means like involving them in the whole modeling process, right? So not just in the eventual decision making part, as in we're sitting around a table and we are doing something, but at least making sure that everything that has to be on the table is on the table, and that all the perspectives are in there, and that we include the more weirder perspectives of people, and that we at least have involved the domain experts and the people that need to have a say in this without bypassing them in a way. So it can very well be that eventually one person is making the decision, but then at least it's a very informed decision based on all of the input perspectives and then all of the other stuff that's in there. So I think there's a nuance there in how to approach that.
Yeah, so from a decision theory perspective, like first of all, decision theory always encapsulates uncertainty. So no matter what you decide, you have to learn to live with the fact that you might not have taken the best option forward, and that there will be a sort of penalty or a cost to changing the direction or to take another option of your decision. So I think if you take uncertainty into account when you're designing something, like you only know when do you know if you picked the right architecture or when you picked the right design? I mean, you can only know that years later or when you have actually worked with that for a very long time. So learning to sit with uncertainty is something that you should do, which should sort of take away the decision paralysis a bit. And another helpful trick that I thought is a heuristic from them. And it's basically, so you have all these options and you need to gain more information in it. So we have different designs in our scenario here. And then basically they ask themselves, like, if you had a fortune teller or a wizard, and you could ask them one question about all these options, like what piece of information would you ask to this fortune teller, which can tell you because they know the future. And by looking at like that, then you basically go hunt for that information. And then with that piece of information, you make the decision and you move on from it. Mm-hmm. That's sort of how they do it, to not get stuck or not to make, keep analyzing and how to move on from that.
Yeah, and to add in that way is what we usually see is if you do collaboration, well, we've done about 30 people designing new boundaries for teams, right? And what you usually see is that at some point you get familiar opinions, but you have this divergent thinking, right? But at some point people get annoyed because you're going on, well, we're now going there and there and there, and they're like, no, let's keep to the focus of this outcome, right? But that's not how normal groups work. They're always going that way. The problem is, when do you go convergent thinking? And that's why you need a sort of, in this book, the Facilitator's Guide to Participatory, there I go again. Participatory design. They say that's the groan zone, right? That's the where it gets uncomfortable because too many ideas, and how do we go back? Now the thing what we did with 30 people is trying to get them back with some liberating structures, right? Designing that in multiple groups, but the outcome, like Evelyn says, it's an informed decision. That outcome of the 3 ending models is taken by a group of 6, and they make the decision. And from there, you can go back to the group and say, okay, this is the decision. And if there's nothing against it, we will do this. And that's the second part that usually goes wrong, is how do we go into decision making? Does everyone have the space to say what they want? Or is it a command and you need to do this? And usually most people come in as, you have anything to say about the decision, but they already took the decision. Then just take the decision and ask, what does it take for you to go along with this decision, right? But that confusion goes wrong. How much can I buy in, or can I decide in this group?
I guess what I'm still wondering is, so let's imagine that I'm a software architect somehow responsible for, or at least that's what it says on my business card, and I'm in a project and I make a decision, like I do it by myself. Should I feel, when would that be a good option to do it by myself? Is there any such scenario, or should I generally feel guilty about making decisions by myself, not involving other people? What's your take on that?
Yeah.
You know, I'm wondering how much should I, if the answer is, well, you should basically do all the decisions with other people around, it's sort of a rule of thumb that says I should basically walk around and I should hardly ever make a decision by myself. So is that a valid rule of thumb? Is that something that you would advise?
So there's a time constraint. Yeah, there's a time constraint there, right? That's what we do, in my opinion. If there's a time constraint, you sometimes need to make that decision. But if you're unable to explain it to people why you make that decision, and you're sticking through that and you cannot explain it, then it's probably the wrong decision to make. First of all, you need to include more people. A better thing, what I would do is, if there's a time constraint, is say, look, we have a time constraint. I've picked 2 hours in this session, and we are going to make this decision. And we're not going away until we made this decision. So focusing on that we, that together. If people cannot make that decision due to all sorts of factors, right, social factors, then at the end, I still make the decision, because you know what, we have a time constraint. If we don't make this decision, business, money, or value, or business concerns are at stake, right? So you can still make the decision if it's explainable, and always ask that final question, right? This is the decision, so we're going to do this. What does it take for you to go along with this decision? Is also a very nice and valid way of doing it. But that second question never get asked, right? We're going to do this, but is there something I can do for you to make this decision more bearable? Right?
And I think that, I mean, if you would make no decisions on your own anymore, then you will have a very hard life, I think. And I mean, it's also about what's the impact, right, of this decision? I mean, are we talking about something big and impactful for a lot of people or not? Who's affected by it? That sort of stuff. And I think my rule of thumb usually is, when it comes to decision making as well, I want you, and you never know it for sure, but make informed decisions. So when you make a decision, know at least what's going on, right? Am I missing any perspectives? And make sure that you have that information when you make that decision. So asking yourself, okay, in a weird world, what am I missing here? What am I not seeing? Where are my blind spots? And then ask for that. But making a decision on your own, I would definitely do that. Yeah.
You can always add. Yeah, you can always add that. Sorry for interrupting. That's what Evelyn says. There's different stages. Like, this is the problem. Come with solutions. This is the problem, and this is what I think we should do. Then the next one is a proposition, right? This is what we're going to do. Or do you see anything that is critical of not doing it? Or the last one is the command. There's 4 stages of how you can make a decision. And the left one takes more time and the right one is instant, right? But every time you make a decision, people will start showing resistant behavior. That's a fact, actually. Yeah. So how much can you handle? How much resistance?
The other question that I'm wondering is, so I have a background I studied computer science, so I consider myself a technical person, and it seems that we have quite a diverse set of people here in the stream. So for technical people like me, what is sort of the typical mistakes that you see such people making, and what would your advice be to improve on that? Like something that is obvious once you don't have this, you don't have that technical background, but rather a background in decision theory or in social things.
So if I understand the question right, as a technical person, what should you avoid doing? That's sort of if I rephrase it. I think, like, when we're talking about designing, then a lot of the technical aspects are still can be left open and can be discussed at a different moment. So when you're really sort of designing the software, see how they fit into boundaries and all that, whether or not we should use this for a database, of whether or not we should do something sync or async, like those are all technical decisions that you can postpone. So if you are a technical person, in those moments, try not to find a solution, but really try to understand the problem that they have, how that divides into boundaries for them, like how do their processes flow, how do all those things interconnect with each other. So really focus on the business and how that connects and how that has to communicate with each other, instead of trying to already think of a solution that would fit software. So that is one of the tips I would give. I don't know, Kenny, Evelyn, if you have anything else to add.
No, I think that's what I would say as well. And I think especially, indeed, every technical choice has more social implications, right? So be aware of the implications that it has on other levels as well, and be aware of those. There's more going on. When you put more than one people in a room, group dynamics start to happen. And I think it's very valuable to at least pay attention to those and try to manage them is maybe the wrong word, but at least be aware of them, that they're going on, recognize these things. It's also what we talk about in some of our other talks and workshops. But I think that's a very valuable skill to have. You don't have to be an expert, but at least know that it's going on and see, okay, so if we are now talking about this technical stuff, what are the implications for the other world, let's say, for social aspects, cognitive aspects, behavioral aspects, what does it do? And have that conversation with the people in the room.
Mm-hmm. Yeah, I think that's, to add to that, is there, if you have an opposing view, is there a problem? And you want to agree on the problem first, and then move to a solution. So if you're saying, no, I think Kafka is the better technology. Well, first step back and see, are we actually sharing the same problem? So the why, right? Why do you want this? So if someone poses like, we need to do microservices, okay, but why do you want to? So look for the why, and it can be on a technical level as well. So that's the, and then when you're in that phase of, okay, why? Then I always ask the other, okay, who sees this different? So I make it safe to ask for the differentiator, right? So, okay, who sees it different than microservices? And then someone might say monoliths, and maybe some people are laughing, but there's always, you're never alone in that why, right? In that, why do you want that? Well, it's easier, simpler. Okay, why do you want that? Well, easy, simpler. Who else wants it? Yeah, the rest. And all of a sudden, you see that everyone wants it easier, simpler. Only the one thinks it's microservices, and the other one thinks it's a monolith. Okay, now we have a more interesting conversation, right? We both want the same, but we have different solutions. Why is that? How is that? What are the consequences, etc., etc.
Mm-hmm. I think that's very good advice. There is one thing on the chat. I'm not sure what to make of it. So Rudolf said, hello, is it better to make a decision at all, or the same decision will be taken for you by somebody else? You won't be happy. Not sure what to make of it. It somehow feels like an advice to rather make decisions yourself, because otherwise someone will enforce a decision on you. Any comment on that? Anything that you would say to that?
Yeah, in decision theory, there's this concept that not making a decision is making a decision. That not doing anything at all, it's an option to not do anything at all. It is an option for, to let someone else make that decision for you if you don't want it. So is that good? It depends. If like, for example, I'm going to make a couple of assumptions here with that question, but if it's that you're trying to make a collaborative decision and you just cannot get out of it, then by all means take that other option and let someone else decide for you. Like, get out of the I don't know the English term, the blockage, get out of that blockage and actually pick that option by letting someone else decide. And often if you just mention that, we'll just go for that, then you can also sort of like continue to it's sort of, oh no, but we'll decide like that other option. If you say like, hey, this is an option and I'm utterly willing to take it, and you can, sort of move forward sometimes as well. I made a few assumptions here, but I hope that sort of answers your question to the person who asked it.
Yeah, I think it's a very good point. Not making a decision is a decision, and sometimes not making a decision yourself is a very good idea. So I'm afraid we are at the end of the time box. Can you?
Yeah, I've added a blog post in the links later on from Rebecca that talks about least and last responsible moment for architecture decision making. That's all.
Exactly, that's a very good point. So we will have a few links on the show notes. In particular, I learned about a book today that is called "What Is Your Problem?" So that's an interesting book. At least the title sounds interesting. So we will put those links on the blog. And thanks a lot. Thanks a lot for being here. Thanks a lot for all the information and the input. And I hope you have a pleasant, great tutorial on Friday that is actually booked out, as far as I know.
It is, yeah.
It is.
Okay.
So, thanks for having us.
Thank you for having us.
Enjoy the rest of the evening.
Yeah, thanks. go.
Hi there, welcome to the second interview at Software Architecture and Stream from OOP. My guest is Rick Marselis, and we are going to talk about quality engineering. When you have any question you like to ask Rick, I will forward it to you. Please use the chat at YouTube or Twitch. So I would like to start with the easy part, Rick. Could you please introduce yourself to the audience?
Yeah, thank you very much, of course. Well, my name is Rick Marselis. I'm a principal quality consultant at Society in the Netherlands. And being a principal quality consultant means I do 3 different things. I do consultancy and coaching assignments for clients, mainly part-time, sometimes short-term, like 1 or 2 sessions, sometimes for a longer period, but mostly only 1 day a week. Second thing I do is research and development, and that focuses on the area of quality and testing. And I've been involved in research and development for about 20 years now. And the good thing of doing research is that you get new insights, new ideas, and are allowed to share these, for example, in talks like this with you. Well, that's very nice. But also in, for example, books. So we created a book, and I will probably tell a little bit more about it later. And the last thing I do is training courses, and that is obviously also in the area of quality engineering and testing. And it's both specific training courses for organizations, but also certification courses where people can take an exam, and then it's more standardized course. And I'm one of the people who created the TMAP certification scheme that was launched, it's now 1.5 years ago. Yeah.
Mm-hmm. And TMAP is part of quality engineering, or was it what is TMAP exactly?
TMAP is the body of knowledge for quality engineering and testing. And well, actually, to give you a little bit of history, that's the good thing of having my whole bookshelf at hand. This is the very first TMAP book, and by the looks you may already see it's quite old. It is 27 years ago. And back then, TMAP started as a method for testing. And today, especially with the launch, oh, now I can't get it back. I'll put it on my desk. I'll store it later. But today, it's not just about testing, it's much broader. And that's also the subject of this talk, for what's the different thing. And it's, of course, the subject of my presentation on Wednesday.
So we are going to talk about this a little bit. Your title is a bit catchy, I would like to say, was quality engineering instead of testing. Why and how? First of all, could you explain quality engineering to me?
Well, what we mean with quality engineering is that people involved in IT delivery take joint responsibility for delivering the right quality at the right moment. So you want to have a cross-functional team with multiple people that together take the various tasks. And the difference, and that's also why my title, quality engineering instead of testing, if you look at the history, and the very first book I know about testing is this one, The Art of Software Testing by Glenford Myers. This book is from 1979, when even I were not in IT. By the way, I didn't tell that when I introduced myself, but I have been in IT for more than 40 years now. But back then, Glenford Myers defined testing as find the errors, then you can fix the errors, and then you will have perfect software. Well, a couple of decades later, Jerry Weinberg created this book, Perfect Software and Other Illusions About Testing. So Jerry Weinberg made us it very clear that testing will not make sure that you have perfect software. And I think you will never have perfect software, but it should be good enough. And therefore, with quality engineering, we try to both build quality in from the start and make sure that we get the right information about the quality level, so that or we have confidence that it is good enough for the goal that we have, or when it's not good enough, then you have information to fix it. But back in the time of Glenford Myers, it was more like, we know there will be problems, but we will fix them at the end. And today we want to build quality in from the start so that we don't have to fix at the end. So yeah, that's the basic idea.
But you're saying in the title, instead of testing, are you really saying that with quality engineering, you can leave testing behind? So no unit tests, no end-to-end tests, or is it just to get the audience inside of your talk?
No, what I mean is the main focus. Mm-hmm. Often people, when they talk about quality, they start with looking into quality when testing. But you should start looking at quality at the very beginning. And to me, testing is part of quality engineering, but it's only one part of quality engineering. So you should broaden the perspective to the whole IT delivery cycle and all the activities involved. And by doing that, for one thing, you reduce the need for testing, because often people feel a lot of need for testing because there are so many problems, and they try to find all the problems and fix them. And by building in quality, you need less testing and especially less retesting. On the other hand, also, some people think that testing is to be done by a certain group of people, and other people do other things. And we argue that in quality engineering, everybody should work together and just create the stuff they need. And of course, you need to do some testing. But I think that like a decade ago or so, there was an awful lot of focus on testing, and everybody tried to make us believe that testing was the most important part of IT. And basically, I think testing is not that important. And here who's saying it, because testing is of course, part of who I am, but still, basically, if you build perfect software, you don't need testing. Now, it's impossible to build perfect software, so you always will need some testing, but don't overdo it. Another thing is, do we need testers as separate people or not? And that's a huge discussion nowadays. And my simple statement is, in a modern agile or DevOps team, you need testing skills. You don't necessarily need people who call themselves a tester. But you need to be able to do all the testing tasks that are needed. So you need some unit testing, you need some integration testing, probably you need some test automation, especially for your regression tests. And also you will need some acceptance testing. Do you need a specific tester? Well, not necessarily. On the other hand, the interesting thing is that if you are a team and you need to build, let's say, Java software, then nobody is surprised if you say, we need somebody who is specialized in creating Java software, because we need to build it. And then when we need to do some testing, people often are surprised that you need somebody who is specialized in testing, because then they say, but everybody can test. Well, of course, everybody can bang some keys, but not necessarily is everybody able to actually do a real good test. So in the end, I would say we still need professional testing people. But then you have a discussion. And actually earlier today, there was a discussion on the internet with a group of people. What should quality and testing professionals be called? Do we call them tester? Because some people think tester doesn't sound very well. Should we call them differently. Should we call them quality engineer? Well, some other people say, yeah, but what do you build? Because engineer creates stuff. So is that a right term? In the US, often they call them QA, which then stands for quality assurance. And I often joke that QA is a perfect abbreviation because that's what testers do all the time, because it stands for question asker, because testers ask questions all the time. And I think the basic idea is, if you care about quality and are able as a team to have that care for quality, then you will be able to build things and create stuff that is very valuable. And I think nobody in a team should only do testing, and nobody in a team should do no testing at all. Because with responsibility for quality comes that you take responsibility together, and then together you make sure that you do all the activities needed to ensure quality.
So you're also saying that quality engineering is something which has to be there from the start of a project, if I understand you right. So whenever I get or collect my requirements, there should also be the focus on quality. So which quality goals should I keep in mind when implementing this one? But I think the most projects I know about, this topic is left behind till the end. So we find out, oh, performance is necessary because we have to deliver stuff just in time or something. So we should focus on performance right now, and that's too late. I know this, but I think there are many projects out there where the problems are already there, and maybe there are some people outside who hear about this quality engineering and think, wow, this is great, but I cannot restart the project right now and focus on quality. But so long story short, can I introduce quality engineering in a project which has already problems with quality, or is it too late and there's no possibility for this?
Well, let me give two answers. One is, in a perfect world, of course, you care for quality right from the start. And luckily, I see more and more situations where that happens, because people do refinements of user stories before they put the user story on their backlog. So they know it is the right entry quality. It needs to comply with the definition of ready before you put it on your sprint backlog. And that's also a part of quality engineering. Now, if you are in a situation, and especially if it's a large, long-running project, then if somewhere down the line you find that there should be more attention to quality, of course you can still start adding ideas from quality engineering. And there are many different things that support quality engineering. Now, one of the things I think is very important, what we did in the book is we made an appendix with the quality characteristics. And well, I'm not sure if people can see it on the screen. We have the quality characteristics from the ISO standard. And here's a picture of the ISO standard. And it gives you functionality, which is something that everybody always thinks about, because that is what the system should do. And you have 7 non-functional characteristics, being performance, compatibility, usability, reliability, security, maintainability, and portability. And these are things that, like you gave an example of performance, often are missed in the beginning, but the sooner you think about them, the better. And in some instances, you just think about them and then say, okay, we don't need to worry about it. Let's say portability, for example. When I started in IT, we just had 2 big mainframe computers, and nobody cared about portability, because if it ran on one mainframe, it also ran on the other mainframe, and that were all the computers we had. so nobody cared. Today, with all these very nice smartphones, yeah, portability is a huge issue. So probably if you are in a mobile app development project, people will have been thinking about portability. But if you are in a more of a legacy kind of project, well, maybe people have forgotten. And then it's good to ask the question, is this something to worry about or not? And then I come back to the joke of question asker, because that's often what people with a quality mindset do, is just think of some things, and instead of thinking, probably it's not important, no, just ask, is this important? Yeah, and also when you want to change the way of working in a project, it's never too late to make small changes. You can't change the whole world on one day, but you can make small steps. For example, by doing retrospectives in a better way, because I see often that after a couple of sprints, people don't do real good retrospectives anymore. And the retrospective is the opportunity to improve together. And another thing that I often notice is that in retrospective, people they go for the quick wins. So they want to have a change that will improve their situation within the next sprint. And of course, if you decide to make, let's say, a template or something like that, then that can be done. But often the real improvements take more investment. And recently, for example, and I came across some people who struggled with testing, and they said they had too many test cases, they didn't have time to run them all. And when we looked at their test cases, there were a lot of actually double test cases. Of course, they were not exactly double, but they were testing the same kind of functionality. And I came up with the idea, why don't you look into test design techniques and properly design your tests? And they said, yeah, but that will take way too much time. So, well, of course, like with every improvement, in the beginning, it will be a little bit hard. If you learn to ride a bicycle, the first time you also fell over. But after you have learned it, it goes faster and better, and you don't need to think about it. And the same is, for example, with test design. If you use test design techniques to properly design your test, then with very few test cases, you can have a good coverage and thus have good confidence in the application. And what people often forget is that testing as such is not only dynamic testing, which is running the system, but also static testing, like code reviews. And all too often I come across developers who don't think code reviews are necessary, or they don't want anybody else to look at their code. And by the way, there are also very nice tools to do code reviews. And that is the first basic step towards better quality.
So you've shown the Gien stuff. I don't know if it's the right term. So the performance and portability and so on, they are pretty much goals inside of these Gien norm. But I know you can't focus on all of them in one project. You have to pick the cherries of them. You have to decide which are the most important ones for your project. Do you have any tips on how you can decide? I think you have to talk to the stakeholders perhaps, but are there workshop formats or something like this, or do you have any tips on this?
Well, my first tip then is the so-called quality engineering strategy. And actually we do have a template for that on our website. Actually, I can share my screen.
You can share your screen.
So, yes. Let me do that. Share screen. Chuck. And then share.
Yeah.
Okay, so you can see my browser now. I have gone to tmap.net, which is the body of knowledge for quality engineering and testing. And then I'll go to templates. And then I'll go to the quality engineering strategy table. And I'll open it. Oh, this is fun. Of course, it opens in Excel. So now I have to share my Excel screen. So just a moment.
Yep.
And then, of course, I hope Excel opens quickly. The funny thing is, in 40 years, I have often heard computers will be faster, but still I'm often waiting for computers to perform things because they got faster, but also the tasks they have to do become more complex. So what is a quality engineering strategy? And I'll try to make it a little bit bigger. Oh, this is too much. Well, this is okay. The idea here is that we have some items, and I better open the example. So we have a user story. Oh, now I have to increase the size again. And for a user story, we do a risk analysis. And the first thing you need to think about is what are your important quality characteristics? So here we have a user story where we thought functionality and performance are the most important. So coming back to your question, of course, you can't focus on everything because then it wouldn't be focus. So in this situation, we decided functionality and performance is the most important. And we determined the risk for this user story for a specific quality characteristic. And usually determining the risk is done with a quality risk assessment. You may know that as a product risk assessment, but we prefer to call it a quality risk assessment. And that can, for example, be done by risk poker, which is done together with planning poker. And if you have a risk class A, which is the highest risk, then you assign quality measures that go along with that risk class. And here we see that we have 4 groups of quality measures. And the first group is, oh, sorry, I'll skip the pop-ups. So the first group is the preventive quality measures. And that are quality measures that you do, so activities you do to build quality in. And an example there is in the first row is pair programming. So you have 2 people working on one piece of code, and by doing that, it will be higher quality. The intensity we chose because of the risk class is indicated by the bullets. So 3 bullets is high intensity, and pair programming is an example of high intensity preventive quality measure. Mm-hmm. We also have static quality measures, dynamic quality measures. They are known previously as static testing and dynamic testing. And we have corrective quality measures to change something afterwards. And an important example of corrective quality measures is refactoring. So there's not a direct reason to change something, but refactoring is a good way of improving the quality of your overall system. So that is an example of how you could implement quality engineering. And I don't think we have time to tell all the details, but well, if people like, they can just download this. The website tmap.net is just a free website. We like to share our knowledge because over the 27 years that TMAP exists, we have learned that sharing knowledge is much better, not only for the people that get that knowledge, but also for ourselves, because a community grows. We get feedback. By the way, as you can see, this is a 0.8 version because it's still in development. So it's the first version that we put public. But if people have feedback, then please let us know, because we like to incorporate new visions, new ideas, and improve the quality of this product also.
So tmap.net is a good starting point for me to start my journey in quality engineering.
Yeah, I would definitely say so.
So we have 5 minutes left. You are also, maybe you can talk about your tutorial on Friday in short. So do I have to visit your talk on Wednesday to visit the tutorial on Friday, or is it a totally different topic?
Well, of course, it is both building on the same ideas, but the contents of both things are different, because my talk on Wednesday is about what is quality engineering, how does it align with various IT delivery models, and also what's its relation to testing, like we just saw. And my tutorial on Friday is about test design and about one specific way of test design, because in TMAP, we distinguish two main groups of approaches to test design. One is experience-based testing, like, for example, exploratory testing. And the other is coverage-based testing, where you can guarantee a certain level of coverage. And in coverage-based testing, there you find the so-called test design techniques that in a structured way deliver you your test cases. Now, in TMAP, and I'm not sure if I can quickly find it, but I think I will. We have distinguished 4 groups of test design techniques. And I'm quickly trying to browse through that picture. I hope it is a little bit visible, but we have 4 groups of test design techniques. Well, I'll read them out. Yeah. So the first one is process-oriented test design techniques. And that's, for example, state transition testing or path testing. The second group is condition-oriented test design. And the difference between process-oriented and condition-oriented is, let's say we are testing the access to a roller coaster in a amusement park, which is actually the example from the book. You need to be at least 120 centimeters. So small children are not allowed. So they look at your length. And to be able to test that, you can, of course, just test based on the length. That would be data-oriented testing with, for example, boundary value analysis. But you can also test the whole process of this thing. So how do we let people in the roller coaster, and we need to measure their length, and then we have different possibilities whether they are allowed or not. Or you can look at conditions, and specifically if there are multiple conditions. Now, the tutorial on Friday is all about condition-oriented testing, and there you will see that there are different ways of coverage, different coverage types, and we will look into modified condition decision coverage, which is a combination of high coverage but not too many test cases. So it's actually an optimal way of doing it, and sometimes people find it's quite difficult. And normally in a training course you learn modified condition decision coverage in just like 1 hour. And I think 1 hour is too short to really get an idea what it's all about, especially if you need to integrate it in a test design technique like elementary comparison test that we are doing on Friday. So I'm very happy that it is a full day tutorial, because then people really can practice. I think we have 5 or 6 practical exercises, and people can step by step learn how to do it, and by really practicing they, well, not only get the idea and the theory behind it, but also know how to do it. And of course we will use some Excel templates that again they can find on tmap.net, because that's where we like to share all our knowledge.
That sounds interesting. So we're nearly at the end of the time, but I would like to ask you one last question. If you could only give one tip to the audience to improve their software projects right now, what would this be?
That would be take responsibility for quality together. So joint responsibility for everybody in the team. and be aware that quality is not just the task of a tester. Quality is the responsibility of everybody. And also by having that focus, my experience is that it also will make the whole IT delivery process much more fun, because it's not us against them, but it's all together creating something great.
Very nice last word. Thank you very much for being my guest this evening, Rick. I had
You're welcome.
very much fun with your interview, and I think it was very interesting. I hope the audience thought the same about it. Yeah, and I wish you very much luck for your talk and your tutorial.
Thank you very much. I look forward to meeting everybody at the conference, although it's virtual. And I hope to see a lot of people in my talk and my tutorial as well. And thank you very much for interviewing me.
You're welcome. So bye.
Bye-bye.
So welcome everybody to the last part of the English evening today, and my guest is Scott Ambler. So Scott, do you want to say a few words about yourself, who you are and what you're doing?
Yeah, hi, I'm Scott Ambler. I'm one of the co-creators along with Mark Lyons, the Discipline Agile Toolkit. I am also the thought leader behind the Agile modeling and the Agile data methods from the early 2000s. And some of you may have seen me speak at earlier OOP conferences in the past.
Yeah, and you're also the author of Refactoring Databases, the book that I lent to someone and he never returned it. And it's obviously a very useful book. So what we are going to talk about today is data technical debt. And you have a talk about data technical debt as well as technical debt at the conference. So let's start with some definitions. So what is technical debt?
So technical debt is a measure of quality or lack of quality. And, the common metaphor is just like you have financial debt, credit card debt or bank debt or mortgage. You have technical debt. So you have this poor quality throughout your organization, throughout your assets. And it has an effect on your ability to respond and to evolve your systems, evolve your assets.
And the other term is data technical debt, which I assume you coined. So what is data technical debt?
Yeah, I'm not completely sure if I'm the one that coined it. I might have, it's something that a bunch of us have been bouncing around for a few years now. And it's basically recognizing that there are data quality problems and that some aspects of technical debt are actually focused on the data, not just the code, not just the systems. And I think it's something that's been overlooked and is actually a very serious problem in most organizations. And we tend not to deal with it in many cases because what I tend to call the cultural divide between the developers, the systems people, and the data people, and they don't talk well with each other still after all these years. And so where technical debt is a reasonably common thing in the developer world, it's not that talked about in the data world, and that's a problem because we have very serious data quality problems out there.
Mm-hmm. So one thing that I'm wondering is, what are the consequences of data technical debt? What are some experiences? Obviously, it is something that is important to you. So have you seen any consequences that are very severe, or what made you think about it, and why do you focus on this subject?
Yeah, so if you look at some of the, so first of all, I'll talk about some stats. So Gartner, a couple of years ago now, basically came out and said that the average organization loses $15 million a year on due to data quality problems. Now this is like mid-sized to large organizations, I would imagine. But HBR, working with I believe IBM, a few years ago revealed that the U.S. economy loses $3 trillion a year because of poor quality data. So it's a reasonably important thing to be looking at. But to actually take a look at what's happening in your organizations, it results in poor quality information, which then results in poor quality decisions. And I think that's where the real issue is. People don't have the access to the data that they need. The data is old. It's inconsistent with each other. You don't actually have the information that you need. Like, it's probably out there, you just can't get it, or you can't. It should be there, but it's not because the data on the back end is messed up. So there's a bunch of reasons why you can't get the information that you need right now. And that's impacting your ability to make good decisions.
So what you're basically saying is that there is poor quality of data. So I imagine, for example, that I recently moved to a different city. So maybe there is still the address somewhere around, and they still locate me in Berlin, even so I'm living in Kaiserslautern nowadays. So if I think about that kind of problem, that's quite a different problem from code quality. With code quality, me as a software architect or as a software engineer, it is obviously something that I care about and that I can influence. However, data quality, like the address is outdated, that is something that seems to be related to the business domain. So how can I improve that situation, and why is it something that I should care about?
Well, what happens, so say, you would probably care that your mail isn't getting to you or taking a long time to get to you. But what happens if it was your salary data? And, from some reason your raise didn't go through and you're not being paid, or you're in the wrong tax bracket and you're being taxed more than you should have, or you weren't being taxed sufficiently. And then now suddenly the government comes to you and says, oh, by the way, you owe us, you owe us another 30,000 euro because we hadn't bothered to collect it, for the last year or two. So you should care. What would happen to you if your senior executives were making decisions based on cash flow, and the cash flow data was wrong? And your organizations have gone broke because of this thing, by the way. This is not a made-up example. And what was happening was, there a few years ago now, there was an organization where the CFO was maintaining everything in a spreadsheet. And this is a reasonably large organization, so this is might not have been the brightest idea, but they were tracking cash flow in a spreadsheet, and they thought they had more money than they did. So their loans got called, and suddenly they were out of business. And then when all this was audited to figure out, well, why did these guys get wiped out? It got tracked back to a spreadsheet and to a miscalculation in a spreadsheet. And the executives were fundamentally, just basically making poor decisions, thinking they had money when they didn't. So that's a fairly serious problem that you might want to care about.
Yeah, and I couldn't agree more. However, if we stick to that example, I mean, that spreadsheet is probably done by probably even that executive. And me as a software engineer or as a software architect, I've actually never seen it. So how can I influence it? How can I put it on my agenda and improve things?
Yeah, well, you would have to be able to measure things, right? So certainly the systems that you do have access to are probably working with data. So how much of your code, so here's something that a developer should care about. How much of your code do you write that has to translate data because it's coming in the wrong format, or it's inconsistent between two data sources, and you've got to write code that cleans it up, or you've got logic in the UI that is capturing data or displaying it in a different format, so that way people can do whatever they do with it, and then you got to translate it back into whatever the data source wants. I would care about that, and because the fact is that technical debt in your code is the result of poor data quality to begin with. I would recommend fixing the real problem, because the problem is not the technical debt in the code. The problem is the technical debt in the database. And you have now, so not only do you have that technical debt, now you've got all this code technical debt, and you got to maintain it and all that good sort of stuff. And is it correct? Who knows, right? Is your data being tested? Or worse yet, you've got this, and you'll have this shared data source where your system accesses it and does something with the data. My system accesses it and does something with the data. Are we working under the same business rules? Or am I doing things to the data that then have an effect on your system and vice versa? And now we've both got code on each of our ends cleaning up the mess that the other guy created. And then multiply that by hundreds or thousands, depending on how many systems access that data source. So it adds up. So it becomes an issue of coupling. So data sources are in most organizations are a source of very high coupling. Because you got all these systems accessing the same data source, right? So because they're a source of high coupling, anything coupled to it has got an issue if there's a quality problem in the data source.
So 2 questions. First of all, so would you recommend to go to the business people and talk to them about data quality and how it should be improved? Because maybe they are the sort of source of the data technical debt. Is that something that you would advise?
Sometimes, yeah. Well, certainly, you should, regardless of what type of technical debt you're talking about, you should be helping to educate the business because they're making decisions around that, around whether or not the technical debt gets injected to begin with. And they're certainly making decisions around whether or not you're going to invest in fixing and addressing those quality problems. So, yeah, the better the business understands, probably the better shape you're in. But certainly, there's issues around, certainly, they might be creating bad data technical debt, without a doubt. But there's also, some of the decisions they make, the classic, got to be on time and on budget. So it's easier just create another data source rather than use our existing ones, right? So now you've got storage issues, you've got consistency issues, and all that good sort of stuff, right? And then all the usual, you gotta maintain and support multiple things. So yeah, I would help the business understand that, but it really is on the developers and on whoever's responsible for data stuff in the organization to be working together more effectively to ensure that either you're injecting less data technical debt, but also that you're paying some of it down appropriately.
And the other thing you just mentioned that if you have a shared database, that leads to very tight coupling. So what you advise to stay away from shared data sources and shared databases? There is this, I'm not sure whether you're aware of that, but there is this famous tweet that where there is a Star Wars Death Star and a few TIE fighters, and it says those are small microservices and that is the large database, this sort of Death Star. So is that something that you sort of can relate to, where that do you think we should get rid of those centralized databases and that they are sort of the core of the problem?
No, it's not. No, that's wacky. That might be a problem in some organizations, but it's not the technology. This is where this is part of the cultural impedance mismatch. The developers don't get it. If it's a microservice with its own database and behind the scenes rather than one big database, who cares, right? You can still have significant problems with that. The problem that the microservices guys are completely blind to is what do you do on reporting? What do you, how do you get all this data out of the microservices and then report against it into a data warehouse and BI and all that good sort of stuff? So the fact that you split them into microservices, maybe you've architected things slightly better, or maybe you've just blown it again. Because the fact that it's a large centralized database tells me exactly nothing. It depends on the design of that database. Like I've seen some phenomenally well-designed centralized databases that the microservices guys would have no hope of ever being as effective as. I've also seen some big databases that are complete dog's breakfast. So it really does depend. So that's not the issue. Now certainly there's the concept of data architecture debt without a doubt, but and frankly that a lot of data architectures are not the greatest. But then again, a lot of systems architects are not the greatest either. So, it really, yeah. So just tell me it's microservices, tell me it's a centralized database, tells me it pretty much nothing. I'd have to go look to see what actually happened rather than, whatever architectural strategy you're using this year.
Okay. So what would your advice be on avoiding technical debt? Is there like some easy to follow things that I should do to avoid data technical debt? Or is there something that a lot of people are doing wrong and that they could easily improve on?
Yeah, there's no easy answer to that, because the answer is it depends. So I guess that's an easy answer. But it boils down to well, I know you're familiar with Martin Fowler's technical debt quadrant, right? So in some ways it gets down to that. And in my presentation later on this week, I'm going to be walking through the quadrant and walking through the implications of what the heck are you doing to make these mistakes in each of these quadrants. But at the end of the day, it really gets down to, do you have the skills to do the job? Are you thinking the architecture through? Are you thinking the design through? Do you understand normalization? There's some basic fundamental concepts in the data world that developers tend to blow. and they're tend not to be working well with the data. Folks may, and those are generalizations, but you'll see developers injecting technical debt a lot, and just normal technical debt to begin with, but because they don't have the skills to avoid it. So yeah, understanding data architecture, strategies, understanding database design strategies, understanding how to manipulate and work with data, all just having the fundamental skills to the job is the critical thing. But yeah, trying to avoid coupling, minimize coupling, which is what have high cohesion, low coupling. That's basically what data normalization is all about when it gets down to it. So having basic fundamental concepts like that is critical.
Mm-hmm. So there is a question from in the chat by Rudolf R. And I guess that goes back to the question around the centralized database, and what he asks is, what about a single source of truth for the origin of data and SOAP WSDL for exchange, and I guess probably also REST nowadays. So I guess the question is, so if we don't use a shared database and instead we have an interface implemented with SOAP WSDL or REST or whatever, would that help? Is that any better than having that shared centralized database? What's your opinion about that?
Yeah, so you're basically talking about having encapsulating access to the data.
Right.
Yeah, classic developer. So, which is great. I'm a firm believer in that. I actually did some of the original work in object relational mapping and database encapsulation. So those are all good things, because you're more than likely reducing coupling when you're doing that. Depends, but more than likely you're reducing coupling, and reducing coupling is generally a good thing. So that's okay. But but it still gets back to, the fact that it's a centralized database tells me exactly nothing. It just doesn't. Because there's very good reasons to have a centralized database. There's very good reasons to not have a centralized database. I don't know your environment, so I can't tell you whether or not that's a good strategy until I know the context. So encapsulating access, generally better. But you've also got to remember, it's not just about what you, as a developer or as an architect or whatever it is you're trying to do, is focused on right now. Data is long lasting. It's persistent, by definition. It's a shared resource. It should be a shared asset. So you need to think long term. You need to look beyond whatever application or whatever it is that you're building right now, and understand the overall implications at the enterprise level. That's what's going to help make or break you. So and bottom line, even though I'm a firm believer in encapsulation layers, at the end of the day, you're never going to have one shared encapsulation layer unless you're a small org, right? The Java guys will be doing their thing, the .NET guys will be doing their thing, the COBOL guys will be doing their thing, and so on, right? And you'll never have one shared strategy. And as a result, you've got more coupling, and you got to maintain it all. So, yeah, encapsulating access is probably better than not encapsulating access. But it's not. But that's only solving one aspect of the overall data quality issue. Mm-hmm. Like if you're encapsulating bad data, I don't care what your strategy is. It's still bad data. So we got to look at the big picture on this one.
Mm-hmm. So one thing that you're saying is it's probably unlikely that you will ever be able to encapsulate data access. So that's a good point. But what you also seem to say is, okay, if I do have such an encapsulation, then there would be more decoupling. So can you explain that in more detail? Because if I do a select statement on a shared database and I do the very same thing, it's just that I do it with REST or SOAP, I get all the customer data, and there is a SOAP service that gives me all the customer data. I don't see how that would increase encapsulation, because it's just a different way of doing the same thing.
Yes, but you're assuming that everybody has a clue. So, and they don't. So, so the idea, if you force everybody through your encapsulation layer, you can then and there's multiple strategies to implement that. You then are in a position where you can start enforcing access control easily in a consistent manner. You can enforce business rules. You can enforce consistent calculations, and that's a big thing. What also happens is, you've got the encapsulation layers accessing the data somehow. It might not just be SQL, but it's something, right? So so you got the encapsulation layer, it's accessing the data, and then all the programs are hitting the encapsulation layer. Now you're in a position where the development tools are generally better than the data tools. So if I am trying to figure out, tracing, where my bugs are and figuring, refactoring and good stuff like that, because I now have my application code coupled to my encapsulation strategy, I've probably got better tooling and better testing and all that good sort of stuff for my code than I do for the database. So I've improved my ability to actually write cleaner code if I've got the skills to write cleaner code, to test better, to refactor more easily. So there's definitely that. And if I've built the encapsulation layer right, then I can enforce critical business rules and calculations at that layer. But here's where it all falls apart. How do you do reporting? How do you get at, the data warehousing and business intelligence stuff is a lot different than the application stuff. So I'm still going to be coupling my DWBI stuff to that data source somehow as well. And I've still got the business rule issue and that, but I've more than likely decoupled. I've more than likely made it easier by doing that with those sorts of strategies than if I had like 100 apps hitting, with the hard-coded SQL hitting the database. But architectural trade-offs, right? Mm-hmm. You're always going to have coupling, no matter what you do, and coupling is the root of all evil. So
yeah, so that's probably like the golden rule of software architecture, I guess. So the other thing I'm wondering is, if there is so much data technical debt, how do you remove it? I mean, obviously, as you said, databases are persistent and there is all the data in the database. That's obvious. So refactoring them is hard. So once you have poor data quality or maybe even a bad database schema, what's your way out of that? What's your advice on it?
Yeah, so it's nasty. You need to gain database refactoring skills and database testing skills. So one of the challenges that we see because of the divide between the developers and the data folks is that there's very different strategies and way of looking at quality issues and addressing quality issues. So generally the data community is trying to get everything right up front, and then they don't. The just nature of the beast. So, or they might get it right up front, but things change on them, or somebody else comes in and fiddles with things. Usual reality type issues. So, unfortunately, they've been slow to adopt basic, things that developers consider fairly basic, like automated regression testing and refactoring tools and good stuff like that. So. Yeah, and that those are generalizations, right? There's some organizations that are pretty sophisticated when it comes to database development, but for the most part, it's like it was 15 years ago. So, like for developers, 15 years ago. So it's early days still in most cases for basic refactoring, and so the question to ask yourself is, if I went into your organization tomorrow and said, show me your customer database. Oh, okay, great, Oracle, blah, whatever. Where's your database regression test suite, automated regression test suite for it? In many organizations, they wouldn't even know what I'm talking about. Whereas if I asked you, where's your regression test suite for that application over there? Oh, here it is, and it might not be the greatest, but you'd still have one, and you'd know what I'm talking about, and you'd probably a good idea what you still want to do to get it better. But on the database testing side, very few organizations have their act together yet. So because they are struggling with basic things like automated regression testing, it becomes hard to refactor, right? As you know, you can't safely refactor code unless you can test it and make sure you didn't break things, or at least have tools that can sort of detect if you broke things or probably broke things.
So is your advice to invest in such tests and build up a test suite? Is that what you would do as a first step, or would you advise for something different? I mean, obviously, as a rule of thumb, but
Yeah, I'd start digging my way out of the hole, right? So if data is a corporate asset, right? So let's go after some of the rhetoric now, right? Everybody said, I don't really run into any firm that will tell me, oh no, data is not an asset. We don't care about data, right? I always hear, well, data is their lifeblood, and it of course is a corporate asset. And then, and as soon as somebody spews that nonsense, and like most of the time it's nonsense, the first thing out of my mouth is, really, what about your regression test suite? Oh, you don't have one? Well, then it's not an asset then, is it? If you've got no plan to, improve it and validate it and all this stuff, then it's not really an asset. So listen to your rhetoric. If you want your data to be a corporate asset, and I suspect you do, then treat it like a corporate asset. Step up and do your jobs. And so start putting the tests in place that you need to validate. Just like I hope your code is considered an asset, at least some of your code is considered an asset. I would also want my data to be an asset, and I would invest in automated tests for that. And I would want to be able to clean it up. So just like, when I see poorly written code that is critical to my organization, I'm going to fix that problem because that's important. If I see poor quality data that's important to my organization, I'm going to clean it up. Right. And it has a very interesting side effect. If you start, like I said earlier, because of the high coupling of systems to the data, even with an encapsulation layer, there's still implied coupling. You go to the encapsulation layer, then you go down to the data, right? If I've got data quality problems, then I'm potentially coupled to those data quality problems, and I'm probably cleaning things up in multiple places now as a result. And even if it's only one app, even my encapsulation layer is doing a dandy job of cleaning things up, I've still got any reporting going on and stuff like that. And there's cleanup, ETL jobs, they got cleanup going on. So this is an expensive problem, and that pervades multiple systems in your organization. So I would highly suggest getting it at the source.
So what I find interesting is what you just said is that a lot of organizations seem unaware that they should have tests for their data. So if I talk to some software engineer who's doing coding, they are usually aware of the fact that they should actually test their code. That seems to be different for the data community, as you said. And that leads me to the question, so if I talk about code technical debt, usually I can talk to an engineer and they say, okay, we know that here are some challenges and we know that there is technical debt and it's bad or not too bad. Do you feel that people are more unaware of the data technical debt that they might have compared to the technical debt that they have in the code? So is it something that is hidden and that is not, that they don't know about because they don't think in these terms?
I think the data people have a pretty good clue that they've got data problems. What they don't have an idea about is how they can actually fix them coherently. They often they don't really know how to avoid it. They've got, a lot of them still believe in the big upfront modeling and all that sort of stuff. And, let's lock down access to the database, not let the developers use it. And that's just not realistic. And you know what? If they try doing that, what do the developers do? They go around them, they create a new data source, and then they do whatever they got to do. So we need to be realistic. And the traditional data quality strategies are what got us into this mess, right? And I go into organizations and they'll be finger pointing, right? It's, the data guys go, they'll be saying, well, we're responsible for data quality, we should have control, blah, blah, blah. And it's the developers who are at fault. Well, okay, so then you just told me you have control, but then clearly you don't if it's the developers that are messing everything up, right? And that's sort of a type of a conversation. But yeah, when they're not talking about testing in a coherent manner, then they really don't get quality. It's just, you know, different than night and day, right? So so they're not doing, because the thing is that, you know, in the old days, with waterfall development, they would do all the modeling up front, they would figure out the database design, and they would throw it over the wall to the developers who would then use it and all that good sort of stuff. And eventually it would get to be tested. So the data guys just wipe their hands of that and not really worrying about testing. And then they would complain about quality problems. Or what they would do is their idea of fixing data quality was to catch the poor quality data in their ETL jobs. That's what the T in ETL is transform. So they would, you know, they'd have this poor quality data source. They would do transformations to hopefully clean it up for the data warehouse, and then they would report on it, and you know, things would happen from there. So, but then and then when you're dealing with multiple data sources, you've got like all the timing problems and RI problems and all this sort of stuff. So, because it's not, you know, a lot of it's not real time, or yeah, it's quasi real time.
So we are almost at the end of our conversation. I will put a link to agiledata.org in the show notes. So if people want to know more about data technical debt and the challenges with that, there will be a few links. Is there anything else you would like to add? Anything that I didn't ask you that you feel I should have asked you?
No, I think this is good. Everybody, I ask you to have patience and to be aware of this issue and realize that we do need to work together. You know, the development community, the data community needs to find better ways of working together, which is what the Agile data stuff was all about. The techniques are out there. I did not talk about any theory here today whatsoever. I did not talk about anything that I haven't done myself, haven't seen myself in multiple organizations. It is possible. There's no magic here. A lot of hard work, but there's no magic. So it's possible. And you know, earlier we were talking about the Refactoring Databases book. Now it's old. It's like about 15 years old. But you know, if you've got the ability to type in code from a book, like, you know, assuming you've got no budget for tools and can't use the internet to download tools, you know, even in that environment, as long as you can type in code from a book, you can do database refactoring too. It really is that straightforward. You know, so, and I would recommend tools, but you know, you can type it in by hand if you like doing that sort of thing.
Yeah, so there is light at the end of the tunnel. So thanks a lot. Thanks a lot for discussing it with us this evening. There will be another episode tomorrow at lunch, then in German, I'm afraid. And I'll put it in the show notes. So thanks a lot. Thanks a lot for being here, and enjoy the conference. And I'm looking forward to your talks, of course.
Thank you.
Thank you.